Project 1.3 ACES Christmas Tree. The main purpose of this project is to introduce the 4060 integrated chip and logic gates, along with the concept of binary counting. This circuit mainly consists of 4 different parts: the RC oscillator, the 4060 frequency divider / counter, the multiple LED circuit, along with the final Christmas tree. Inside the RC oscillator circuit, the oscillator produces a square wave frequency of alternating highs and lows. In this circuit, when power is applied, the capacitor, right here, would start discharging through the resistor, and once it reaches a certain threshold set by the power level, the output of the integrated chips would flip, causing the capacitor to discharge. This charging and discharging cycle creates a periodic signal that can be used to blink an LED, like this one right here. The speed of the oscillation could be controlled through the use of this capacitor and these 2 resistors right here, and the formula would be F equals 1 over 2 times R1 times C. Inside the second circuit, the 4060 frequency divider / counter circuit, the main core component for the 4060 integrated chip is introduced. This chip basically has the previously mentioned RC oscillator built into it. This chip has 16 pins, with pin number 16 and 8 being the input and output for the chip, and pins number 1 to 7 and 13 to 15 being the output pins, pins number 9, 10, and 11 being connected to the 3 analog components used to determine the frequency of the oscillation within this chip, and pin number 12 being the reset pin. Inside this circuit, I have used Q3, Q4, and Q5, all of them connected through a 470 ohm resistor into an RGB LED bulb. This causes the colors inside the RGB LED bulb to flash at different frequencies, creating the illusion of binary counting. Inside this pin, Q3, it actually divides the frequency set by these 3 analog components by 8, since 2 to the power of 3 is 8. Inside this pin, Q4, so on and so forth, it actually divides the frequency set by these 3 components by 16, since 2 to the power of 4 is 16. And so on and so forth with Q5, Q6, Q7, Q8, and so on. The third circuit, the multiple LED circuit. This circuit basically works under the same principles as the previous 4060 frequency divider circuit. It also contains a 4060 integrated chip, and instead of connecting to different pins of the same RGB LED light, now each of these frequency dividers are connected to strings of LEDs, split into groups of 3s. Each pin is connected to 6 LEDs or 2 groups of 3s. This causes these groups of LEDs to flash at different frequencies. For the final Christmas tree, it is essentially the third circuit integrated inside a PCB with the addition of this 5mm diffused slow fade flashing RGB LEDs. Inside this circuit, there is also the core component of the 4060 integrated chip. It is controlled by the surface-mounted 2 resistors and 1 capacitor. On this circuit, there are multiple LEDs all connected to the different pins on the 4060 integrated chip, causing them to flash at different frequencies, creating something similar to Christmas lights. This project introduced the concept of frequency division through the use of this 4060 integrated chip, and it also gave us a basic example on how logic gates could be used to create many things. This is my Christmas tree project. Thank you for listening.